Hello students, today I want to welcome you to my math lesson for PSC paper 1. And in today's lesson there are several objectives that we want to cover. 1 is the different number properties. 2, what is geometric sequence. 3, the different types of triangles. And 4, the different types of lines. So we'll cover the importance of these, and let's start with the associative laws. The associative laws states and say that it doesn't matter how you group the numbers which you calculate first. When you add a plus b plus c, it will equal to a plus b plus c. So if you look and we see the 6 plus 3 plus 4, we switch it around, and instead of having the 6 inside the bracket, now we have the 6 outside the bracket plus 3 plus 4. It's the very same thing as 6 plus 3 close bracket plus 4 is the same as if we add a 6 plus and in bracket 3 plus 4. And when it comes to the multiplication part, you have 2 times 4 times 3. When you switch it around and we have the 2 outside the bracket times 4 times 3, you will get the same answer or the same results. So, in order for you to remember the associative laws, just look at the example, the grouping of how you place it in the bracket. You take out the 6 or take out the other number out of the bracket, and you will arrive to the same answer. Then we have the second law or property, which is the commutative laws or property. And the commutative laws say you can swap numbers over and still get the same answer. Example, if you add 6 plus 3 and you switch around it and say instead 3 plus 6, you will still arrive to 9. So it doesn't matter how you switch around the numbers for addition and multiplication, you will arrive to the same answer. So another example, 2 times 4 is the same as if you switch around and you say 4 times 2, you will arrive to the very same answer. So the commutative laws or properties state that no matter how you switch around the number, you will arrive to the same answer. Then we have the distributive law. The distributive law is the best one of all, but needs careful attention, and this is what it lets you do. Like if we can see, you have 3 times 2 plus 4, and we could break that down, which is 3 times 2 plus 3 times 4. And a distributive property with a little bit more in it. The distributive law states that you arrive at the same answer when you multiply a number by a group of numbers added together as when you multiply each separately. According to the distributive property, like for instance, you have 2 with no sign outside, and in bracket you have 3 plus 4. It means that this 2 with no sign means that you're going to multiply the 2 times 3, use a sign plus 2 times 4. And when you do that, you're supposed to get the same answer. 2 times 3, 6, and 2 times 4, 8. And when you add them, you get 14. Again, you have the commutative property. The commutative property of addition in a little more detail. The commutative property state that you can add in any order. A plus B is the same as B plus A, so 2 plus 4 is the same as saying 4 plus 2, and it will equal to 6. Then if you multiply, 3 times 4 is the same as 4 times 3, and you will get 12 for both of them. So it doesn't matter how you switch around the number, you will arrive to the same answer. Then for the associative property, when you add, you can group the number in any combination. Like we have 1 plus, and in bracket 3 plus 4 is equal to, it doesn't matter which one of these numbers you put in bracket or take out of the bracket, you will arrive to the very same answer. So for this part, you have 2 times 3 times 5, and you will get the same answer as 2 times 3 times 5. So it doesn't matter if the 2 is in the bracket, the 5 is in the bracket, you will arrive to the same answer. Then we have the fourth one, which is the identity property. The identity property states that the sum 0 and any number is the number. So a plus 0 equal a. A good example, 4 plus 0 equal 4. So identity property states that the sum of 0 and any number is that number. Then when you multiply, it says the product of 1 and any number is the number. So it doesn't matter which number you multiply by 1, that answer will be the next number. So it's 1 times 6, of course it will be 6. 1 times 100, it will be 100. So remember the identity property for multiplication. The product of 1 and any number is the number. Then here we have geometric sequence. What is geometric sequence? A geometric sequence is one way to get from one term to the next. You multiply by the same number each time. Then this number is called the common ratio. So in this geometric sequence, as we can see, the number has a sequence of 2, and from 2 to 10, then from 10 to 50, and from 50 to 250. So how do we get from one sequence to the next? If you can see that the sequence that they're using is multiplying by 5. So it means that you have to multiply whichever number you start to multiply to arrive to one answer. That very same number that you multiply with will lead you to the next answer. So how do we get this sequence? It's 2 times 5, which is equal to 10. Then 10 times 5, which is equal to 50. And 50 times 5 is equal to 250. So you see the sequence from 2 to 10 to 50 to 250. In order for us to arrive from one sequence to the next, we're multiplying by 5. And that's how geometric sequence work. If you start to multiply your first number to get to the next sequence, that's the very same number you will multiply to get to the next sequence. And in this sense, we use 5, and so we get from one to the next again. 2 times 5, 10. 10 times 5, 50. 50 times 5 equal to 250. Then here's another example. If you can see in this geometric sequence, in order for us to get from one sequence to the next, we're multiplying by 2. So as long as you could stop and see that we need to multiply from one number to the next to get this answer, then you will just keep on using that very same number that you start to multiply with for a geometric sequence. So the sequence is 1, 2, 4, 8, and 16. And in order for us to get from one sequence to the next is 1 times 2, 2, 2 times 2, 4, 4 times 2, 8, and 8 times 2, 16. So in this geometric sequence, we're multiplying by 2. And remember, whenever you're multiplying for a geometric sequence, the number that you start multiply to get from one sequence to the next at the beginning is the very same number you will always use to get to the next sequence. Then again, the definition for a geometric sequence. It says sequence in which a ratio of any term to the term before it is a constant. Example, you have 2, 4, 8, 16. You multiply the previous term by 2 to get to the next number. So 2 times 2, 4, 4 times 2, 8, 8 times 2, 16. Then they gave us a sequence from 3 to 9 to 27 to 81. So that's if we move from right coming to left. So it's 1 times 3, 3. 3 times 3, 9. 9 times 3, 27. And 27 times 3 is 81. So you see, whenever you deal with geometric sequence, the number that you start with to multiply to get from one sequence to the next is a number that you will constantly be using to find the next sequence. And to continue our lesson, here are the different types of triangles. If you can see them here, you have the equilateral triangle. So what do you need to know about the equilateral triangle? It has 3 equal sides, so you need to remember that. Then you have isosceles triangle. What do you need to know about isosceles triangle? It has 2 equal sides. Then you have the scalene triangle, which has no equal sides. So for the scalene, none of the sides are equal. Then when it comes to angle now, you have acute angle. Acute angle has 3 angles that measure less than 90 degrees. Then you have the right triangle, which has 1 angle that is equal to 90 degrees. And you have obtuse triangle, which has 1 angle which is greater than 90 degrees. So again, for a quick review on angles and triangle. So equilateral triangle has 3 equal sides. Isosceles triangle has 2 equal sides. Scalene triangle has no equal sides. Then by angle, an acute triangle has 3 angles that is less than 90 degrees. Right triangle has 1 angle that equals to 90 degrees. And obtuse triangle has 1 angle that is greater than 90 degrees. Then we want to end today's math lesson by identifying what is a point. A point is an exact location in space or a flat surface. Then we have different types of line. So a line is a collection of points that continues forever in both directions. And the arrow is signifying this on this line. Then we have a line segment. A line segment is a part of a line with 2 endpoints. So the dots at two ends, it shows that the lines stop at both end points. Then we have array. Array starts at one point and extend one direction forever. Then we have an angle is formed when two rays share an endpoint. Then we have intersecting lines are lines that pass through the same point. Then we have perpendicular lines are lines that intersect at right angles. Then we have parallel lines are lines that never intersect. So remember, you could always go back and review these examples. They're very important for you to know for PSC Paper 1. And I encourage you to share this lesson to someone that is going to take PSC. And thanks so much for tuning in. Remember to subscribe for quick access to all the problem solving videos that will be posted soon and the other social studies lesson. So again, thanks so much for viewing and continue to stay in tune.